Welcome to this class. Today we'll be discussing sum and product of roots, and this is under quadratic equation. When we say sum in mathematics, we mean addition, and when we say product, we mean multiplication. For example, if I ask you, what is the sum of 1 and 6? This means 1 plus 6 equals 7. And if I say product of 5 and 6, product means 5 times 6. Product means multiplication, and this will give me 30. So in quadratic equation, we already know that the roots are the solutions of the equations. That is, the roots of quadratic equation is usually in 2, meaning that when you are getting your value is usually what? 2. Either you say x equals to 1 or 4. And by the time we discuss the nature of the roots, we'll understand that it's possible for the roots to be the same, it's possible for the roots to be distinct, and it's possible for the root to be imaginary. So today, in this class, what we want to discuss is to look at the sum and product of roots. There are usually questions in this area in which that we may not need to solve the quadratic equation before we can get the sum of the roots and the product of the roots. What we are saying is that if these are the roots of a quadratic equation, x equals to 1 or 4, if they ask us sum of the roots, simply they are asking us that the root that we get, we should add them together. And if they're asking us the product of the roots that we get, we should multiply them and write the answer. But because of the time limit in the examination, we have methods that can help you to get the sum of the roots and product of the roots without having to solve the quadratic equation first. And that is what we want to do in this class. So let's get started. The first thing is that we will take a quadratic equation to have the roots of alpha and beta. For example, given a quadratic equation with the roots alpha and beta. So if we have this as the root of a quadratic equation, then we know that if let's take the variable to be x, it will be x equals to alpha or beta. This is how our answer will appear. And then we can begin to work it out that x equals alpha or x equals what? Beta. Okay, we are coming from the bottom of the factorization method down to the start. We are doing the reverse of factorization. So we have x minus alpha equals to 0 or x minus beta equals to 0. And I can group them together, x minus alpha bracket x minus beta equals 0. And then I can expand by saying x squared minus beta x minus alpha x plus alpha beta equals 0. Then I can factorize this. Something is common here. Minus x is common. And then I have beta plus alpha beta equals 0. So if you check here, you see that we have minus x out. We have this. Okay, if you use this minus x to open this bracket back, you will get this. Okay, so let's go up here. X squared. Rather than for me to put my x here, I want my x to be here because it's always good for the coefficient of a variable to be behind the variable. That is, the coefficient should be written first before the variable. It's good for us to write 2x rather than writing x2 in mathematics. So since the x is the variable, let's bring x to the front here. So we have minus, and rather than for me to write beta plus alpha, I can put it as alpha plus beta is the same thing. 1 plus 2 or 2 plus 1 will give me the same thing. So beta plus alpha and alpha plus beta is the same thing. And then I have my x that is here. So this is the same thing as this. Then I have plus alpha beta equals 0. Okay. So if you look at this, we have ended up with something tangible here. If you look at this, since the alpha beta are the roots, here they are being summed up together, and here they are being multiplied together. So I can write this, in other words, that I have x squared minus sum of roots, meaning that what? Alpha and beta are the roots. So these are the sum of the roots, x plus product of roots, because here they multiply each other and that's equals to 0. So this expression will always help us. Sometimes they may give us roots of a quadratic equation and we are being expected to find the or write out the equation of that quadratic equation. So we just write out the equation using the roots given, and then we can use something like this. Of course, we are going to see it in the example, and we can go forth by finding a way of comparing this. We still have to make a point out of this. Recall the general quadratic equation. I hope you remember that. The general quadratic equation is ax squared, okay, plus bx, okay, plus c equals what? 0. This is the general quadratic equation. You know, a quadratic equation is such an equation that can be written in this form. Okay, so that's why we call it what? General quadratic what? Equation. So from here, let's assume I want to approach this like I'm actually using completing the square method. Let me divide all through this side by a and divide all through this side also by a. So if I divide by a here, and I also divide by a here. So dividing everything here by a will be ax squared divided by a plus bx divided by a plus c divided by a, and this side also 0 divided by a. Everything here will give me x squared plus b over ax plus c over a equals to 0. So if you look at this, okay, and I get to compare this, okay, with this, just look at this, okay. If I'm to compare what I have here with this, you can see that x squared, coefficient of x squared here is 1, it's also 1 here, meaning that if this is a quadratic equation and this is a quadratic equation, if I'm to compare them, it means that coefficient of x squared here is 1, this one is 1, so they are equal. The coefficient of ordinary x here will also be equal to the coefficient of ordinary x here, and also the constant that I have here will be equal to this constant. So I can write out something like that now, saying that minus alpha plus beta in that place is equals to b over a, meaning that what? Coefficient of x here is equals to the coefficient of x here, and then I can say that what? Alpha plus beta equals to minus b over a. That's if I divide both sides by minus 1, I'm going to have this. So you must note this. The sum of roots, okay, is usually equals to minus b over a. And then we can just state out this one, alpha beta, okay, which is product of roots. You can see is product, is their multiplication, is equals to this one, c over a. So you must note this also. Sum of roots is equals to minus b over a, and the product of roots is equals to c over a. So let's get to see some examples now and see the way we can actually use this in solving questions.